In this problem, I want to calculate the energy change associated with the combustion of 1 liter of ethanol. This is the combustion reaction. And in order to do this, I have to calculate the enthalpy of reaction. So I need the enthalpy of formation. I need them for ethanol, carbon dioxide, and water. We know the enthalpy of formation of oxygen is 0. I also need to know the density and the molar mass of ethanol. Okay? This is a two-part problem. First part is we want to calculate the delta H reaction, the enthalpy of reaction. So I take the and so what I usually do is I like to write below the species what their values are. So the ethanol has an enthalpy, molar enthalpy of formation of minus 277. And this is kilojoules per mole. I'll just write it here, kilojoules per mole. This is 0. The carbon dioxide is minus 393.5, and I'm going to omit the units because it's the same units. And the water is minus 241.8, and I'm going to omit the units because these I'm just writing down what I'm given the enthalpies of formation. Okay, now we know that the enthalpy reaction is the enthalpy of formation of the products because you made them, minus the enthalpy of formation of the reactants because you didn't make them, you broke them apart into their atoms in their standard states. So I have 2, and you obviously multiply by the coefficient, so I have 2 moles of the carbon dioxide at minus 393.5. I add to this 3 moles of the water at a minus 241.8, and now I have added the coefficients times the molar enthalpy formations of my products. I now subtract the coefficients, which in this case is 1, I'm going to put it in there anyways, times the value of the reactants, which is minus 277. And I'm going to put in here anyways, you probably should omit it, 3 times 0. And these are I've subtracted the enthalpy of formation of my reactants times their stoichiometric coefficients. And I bring out my calculator, and this is equal to minus 1235 kilojoules, okay? Now, we got to remember that this is kilojoules per mole of this, per 3 moles of oxygen, per 2 moles of carbon dioxide, and per 3 moles of water. So I'm just going to write that over here. Delta H standard reaction is equal to minus 1235 kilojoules. Now that I know this, I can ask myself how much energy is released when I do 1 liter of water. So I need to convert my liter of water to moles, and then this value per mole. So I start with 1.00 liters of, if I said water, I meant ethanol. Ethanol, C2H5OH. And I know the density of ethanol is 789 grams of ethanol per liter. And I know that the molar mass of ethanol, I can look this up on the periodic table, is 46.07 grams per mole, and this is all for ethanol. And now I go over to the equation, and my liters ethanol cancel, my grams ethanol cancel, and I know how many moles of ethanol are in 1 liter. Now this delta H reaction says that there's a minus 1,235 kilojoules of energy. The minus sign means the energy is released. You always have to have the proper sign in here. For every 1 mole of this. Now if it had been this, it would have been per 3 moles, okay? So it's 1 mole of C2H5OH. And now I get out my calculator, and this is a large number, it's a minus 21151. This number has 3 sig figs, so the final answer is minus 21,200 kilojoules. Okay, so there's a lot of energy in ethanol, which is a fuel.